So yeah, hi everyone. Welcome to this webinar about the new WeDoWind EAWE Test Wind Turbines Committee space. EAWE is the European Academy of Wind Energy. My name is Sarah Barber. For those of you who don't know me, I lead the Wind Energy Innovation Division at the Eastern Switzerland University of Applied Sciences. And I'm also involved in a couple of the different committees in EAWE, and this WeDoWind project is kind of my initiative. So I'm really happy to be presenting this new space today, which has got lots of exciting data and challenges inside it. So the agenda is that, first of all, I'm going to tell you a little bit about WeDoWind for those of you who don't know about it yet. After that, I've asked Sarah, you're going to do that, right? She's going to introduce the EAWE Test Wind Turbines Committee. And then after that, we're going to actually present the new space. We've got some different data prepared. We've got some challenges prepared for you to participate in. Then we've got a special guest, Anna from Badenova, who's going to offer some support for students, as she'll tell you about towards the end. And we want to leave a bit of time to tell you what the next steps are and also to answer any of your questions you've got about participating. So I'll just continue. I can see all your faces, so if anyone makes a funny face, I know that you want something. But if you want to ask a question, maybe just put your hand up using the hand button, or just write in the chat, and I should see it. And if it's something serious, then just speak. Like if I'm showing the wrong screen or something stopped working. Okay, so just introducing WeDoWind. It was founded in a collaboration between my university, also the Swiss Wind Energy R&D Network, which I founded, and then Charlie Henderson from the US, who runs the Enter Alliance and Stacker Group, and Imad, who's also here, who is co-founder and CEO of RTDT Laboratories. And this has kind of been developing over the last couple of years. And so what is it? WeDoWind, we kind of see as a framework, and it's for creating mutually beneficial collaborations. So the idea is that we actually bring together data, people, and solutions. Quite a lot of people working in the area of data sharing, they kind of forget about the people side. Like, people have got incentives, they've got reasons to work together or not. And we're actually trying to find out what people want and actually provide them with some benefits to get them to work together. So the idea is that we give people this win-win situation. People owning data and assets, they have the data, but they need easy access to state-of-the-art analytics. And then the people developing these analytics, the researchers, they actually desperately need data. So the idea is to bring them together in this win-win situation. So the whole idea is to then create these challenges which we coordinate through digital spaces, and multiple spaces then form an ecosystem, which we call it. Actually, WeDoWind can be used not just in the wind energy, but because we're in wind energy, at the moment we've only worked in wind energy, but it's also expandable to other branches. And so for the wind energy area, we've developed this ecosystem where we have 6 different spaces, different challenges running. We have people attending webinars, solving the challenges, submitting their results, sharing the data. And so the idea is these challenge providers, they receive a load of solutions to their problems. They get increased visibility and contact with the research community. And the solution developers, such as researchers and students, they actually get access to real problems and real data, and also gain visibility within the community. This is a picture trying to demonstrate what I've been talking about. So on the top left, we have people who are actually developing solutions, so the data scientists or the students or the researchers. At the bottom, we have the people with the data who provide the challenges, and then surrounding the challenges, we basically bring together the people with the data science and the data. And then we run different lectures, events, workshops, webinars, and then we go to the right, and the idea is that we all learn from each other, we include each other in this knowledge sharing activity, and at the end of the day, we have new solutions. One of the really nice things about it is that anybody can take part, so you don't have to belong to a certain organization, you don't have to fill in an application form, you don't need to know anything. You just need to sign up and you can listen in, you can contribute in whatever way you want. And that's kind of one of the most important things for us, that it's inclusive. At the moment, we have these 6 different spaces. The EDP space was actually the first one, which we ran a couple of years ago, where we did a fault detection challenge with some data from EDP. And we had a similar fault detection challenge after that with the company in Switzerland called WinG. And for the last year or so, we've been running these 2 on the bottom left, the open data exploration space and the data-driven turbine performance space. Recently, we also launched the RTDT space, and this one on the top right is the one that we're going to talk about today. I think my next slides are going to talk about the current spaces a little bit more. Yeah, so the EDP space, we published a paper about the building up this ecosystem. We actually compared, you probably can't see it very well, but we compared like 6 different machine learning solutions. We looked at how well the faults were predicted. And we actually monitorized the gain compared to EDP's original solution in that paper. I can put, actually, if you go to the WeDoWind website, which you must have been to sign up for this webinar, you can see under use cases, you can see a list of papers, and you can find a link there. Otherwise, later. The WinG space, we actually wrote another journal paper. We compared, again, 6 different methods for fault detection. You know, the idea isn't that you can really read this now, but actually the result of that was to develop some data sharing guidelines, because in that challenge there wasn't enough data provided in the right format. So it ended up being really difficult to compare the results. And so we actually, instead of being able to have some interesting or usable results, we actually turned that into a paper about how one should share data better. And that's actually really interesting for this WeDoWind process. Like, how can we make sure the data is prepared in a way that people can use it? And you can read that this link here too. And then we published and presented a paper at Wind Europe this year in April, where we analysed some participant surveys of those 2 challenges. We did a SWOT, strengths, weaknesses, opportunities, threats analysis of the whole system. And again, we came up with some recommendations for actually trying to share data. And then in the open data exploration space, that was originally founded by Charlie Plumley, who was at Cubico, but he's left Cubico. Those of you who know this space, we originally called it the Cubico Open Data Exploration Space, but now the word Cubico's disappeared because Charlie has moved company. But in that space, we're looking at operational energy yield analysis using some open data which was provided by Cubico. And these are some of the results. We've been comparing different energy production results and trying to understand the differences. We're going to be hopefully presenting a paper in Wind Europe next year on that, if it gets accepted. And then in the power curve space, we together with Professor Yu Ding from Texas A&M University, he's actually moved to Georgia Tech now. He created this space where he wanted to, based on his book that he wrote about data science and wind energy, he wanted to compare some different power curve models. And again, we had like 6 or 7 different solutions, which we then ranked based on the areas that came up. It was a blind test. And that was really nice. And we've submitted an abstract for Wind Europe for that as well. And then the RTDT space I told you about, we're actually looking at structural health monitoring. So Imad's here today. He'll talk in a minute about the new challenge. But there's actually a running challenge in that space where he's providing some structural health monitoring data in order to look at operational modal analysis, forecasting damage of the pitch drive, and identifying aerodynamic imbalance. We spent quite a lot of time preparing that data and also preparing a notebook to handle the data. We have some initial results, but what we've mainly done in this challenge so far is we actually tried to, as I said, prepare the data nicely. So we applied this fair data maturity model We published the data on a repository called the Bridge of Knowledge in an attempt to actually improve data sharing, because we realized that the previous challenges had been a bit difficult with the data preparation. We've actually got a blog article on the website about that, and I've submitted an abstract to a conference about it as well. So that's it about the fundamental basic idea of WeDoWind. We've got 1 minute left. Did anyone want to ask something about that before we move on to the next topic? All right, then I'll just hand over to Sarah.
Thank you. So I will maybe take a step back and just introduce the European Academy Wind Energy Test Wind Turbines Committee. So you can take the next slide. So the idea behind this technical committee was to increase the experience of wind turbine operations by the academic partners, and also maybe in the end also include students. We wanted to collect the information of available test wind turbines that the academy had, and also make it possible to have an information exchange between different academy test wind turbine operators and the users, to learn from each other's what problems do we have had, how do we solve the different challenges. And of course also increase the visibility of our test wind turbines, and also see if we can use them more in research. And the last bullet here is to provide measurement data that can be used for simulation, model validation, and benchmarking. And this collects very nicely to the WeDoWind concept here, to connect the ones with the data with the data scientist. But if you go to the next slide, what we have done so far is to collect the data, what different wind turbines do we have, get an overview of them, and some general documentation. What is the measurement possibilities? What sensor do we have? Sample time? What is the control that is possible on the different turbines, depending on what possibilities each test turbine have? What is the access condition, support time, and so forth. And if you take the next slide, we can see that at the European Academy Wind Energy homepage, there is for the committee, we have a map with all the different test wind turbines that is part of the committee. And you can click on each of these ones and get detailed information, and also contact information if you're interested in learning more about some of them. I think that was my last slide, so I have a very short introduction. And I think just this sharing the data is a very good connection to the WeDoWind platform. With that, I hand over to Sarah again.
All right. I just went to the website and put the link in the chat, where that you can actually see that map and interact with it. If you click on the links, you can actually see a document describing each facility.
Great.
Okay. So moving on to this particular space now, we want to give you an introduction to what's on this space. I'm going to tell you how to sign up for it and how to deal with the digital platform at the end of this part. But first of all, we just want to give you an overview of what it includes before you see it, so that it's easy for you to navigate. So the general idea is to bring together researchers and any type of analytics developers from the whole world to solve challenges based on selected data that's been made available by the members of this test turbine committee. We want to build up a community of people who want to solve problems together, so actually see the benefit from working together and using this real data and interacting with each other. And so in this space, in the digital space, we can have challenges. So you can actually create a challenge yourself. At the moment, we kind of create the challenges together with you. But actually, the challenges can be defined by the turbine owners, but they can also be defined by other people if people want to do that. We've never done that actually. We've already all had, up until now, we've had predefined challenges, but there is the opportunity for people to define their own challenges if they find enough people to take part. So a challenge, what is actually meant by a challenge? It's just any task, really. So anybody who wants to challenge participants to do something concrete, like develop a new method for doing something, or to work out what's wrong with this wind turbine, or something like that, where we can actually say it's got a goal, you have to submit the results in a certain format, the results are somehow comparable and we can evaluate them somehow. It doesn't necessarily have to be a competition. You can do it as a competition. You can also do it as a collaborative competition. Like, the goal is not for each team to compete against each other, but to work together to get the best overall result. But at the end of the day, the idea is to have a challenge provider who's running it, and then a load of people solving it, called solution developers. So the data that we have at the moment you can get access to it on the digital platform. Initially, it contains these data sets here, which we actually prepared them thanks to an EOSC Future grant. EOSC is the European Open Science Cloud, and the EOSC Future project has funding for specific projects aimed at improving data sharing. And so we had a grant to actually get this data published openly. So all these data sets I've written here are actually available on Zenodo. So taking part in the WeDoWind is not the only way to get these data sets. You can also just go to Zenodo and Google them, search for them. But the point is that within this space, you can actually, where you can get easy access to them, but then you can apply them to these specific challenges, and you can work together with a community of people on them. So we have data from the Aventa 6 kilowatt research turbine, which belongs to my university. We have some 10-minute SCADA data. And then we have a second Aventa test turbine next to it. They're both located near to Winterthur in Switzerland. The other one belongs to the ETH group, where EMAD works. And we have SCADA data and structural health monitoring data. And then there's going to be a separate data set which just has the SCADA data for a longer time period, because the structural health monitoring data is much higher frequency, so we can't have such a long time period, otherwise the file size gets too big. I think that data file is not actually been uploaded yet, but it's going to come in the next week. We then have 2 data sets from the Chalmers wind turbine, which is where Sarah's from, in case she forgot to say. We can tell by her background, I suppose. And that is a 45 kilowatt research turbine, where we have a separate publication for the SCADA data and a separate publication for the structural health monitoring data. And then we have a third set, which is actually some really unique aerodynamic measurements from 5 different wind turbines provided by Gerard Shepherds from ECN, which he's going to tell you about in a minute anyway. We also got included links to the RAVE. I don't know if you know about the Alpha Ventus research data set. That's available publicly, but you have to go through a signing up process to do it. So we didn't download and then upload the data again on Zenodo. We just put a link to the existing data. And we also included a public data set, which is from the SWIFT facility at Sandia National Laboratories, and that's already been published on the US version of the EOSC cloud is the what's it called, the A2E platform, but you can see the link in the space when we give you access. So that's the data. There are several other people who will be providing data soon. If you remember this list, there are more wind turbines on here. Many of these people have expressed interest at sharing data, but they haven't quite managed to do it yet. So there will be more data sets appearing as we go along. And as part of this grant, we actually prepared the data a bit more nicely than if it had just been given to you on a shared server by the individual universities. So we work together with the company in Germany called NV Connect. My university, OST and RTDT, worked on this as well. We actually brought all the data sets together. So we got all the wind turbine owners to give them to transfer over the data. We created an open fast model actually for the Aventa turbine, which also hasn't been uploaded yet, but it will be soon. And we carried out this fair data maturity model assessment, which I mentioned before, which is actually, I forgot to mention, if you're not familiar with this concept of fair, fair means findable, accessible, interoperable, and reusable. And there's quite a large community around trying to make data more fair. And so you can actually assess your data set to see how fair it is. And there are actually some instructions or some guidelines to improving the fairness. And so we applied some of these instructions to make it more fair, basically. So this involved creating a new schema for the SCADA data. We used the structural health monitoring schema that we already developed from the previous project I mentioned. And we included existing control vocabularies as far as possible. But in wind energy, there's not actually that much available yet. And we then encoded the SCADA metadata using the schema as a CSV file. And we connected the data fields in that to the IEC 61425 terminology where it was possible. And then we just uploaded the data sets and metadata to Zenodo. And it's actually connected to the EOSC marketplace, which is kind of the idea of the whole project, to get the data onto the EOSC marketplace. That requires a certain number of weeks or months, we're not quite sure, to get connected. So we're waiting for that to come through now. And actually what we haven't quite finished doing, what we're doing in the next few weeks or months, is that we actually want to create specific data publications for the challenges. So for example, if one of the challenges is just looking at pitch drive health for the Aventa wind turbine, you don't need to use like all the structural health monitoring data that we've got for that. The file is very big and it's difficult to use. So we want to create individual smaller files specifically for the different challenges. And we haven't done that yet, partly because the challenges have just finished we're just finishing the definition of the challenges. So that should be done in the next couple of weeks. And we also want to help you read the metadata and the data in Python on MATLAB. For the previous RTDT project, we actually provided a script, which was very well received for doing that. And so we're going to prepare something as well to make it easier for you to read the data sets. The ECN data hasn't really been formalized yet. We just kind of uploaded it and didn't really do anything with it. So we're going to work on that a little bit more in the next weeks as well. And then on the more long term, we want to actually improve the schema that we've got and describe all the wind turbines with that schema. But this is a research project, it's ongoing work. So we're just developing this as we go along. So that's the data. And then the challenges, we've actually got 4 challenges available, or at least they will be in the next couple of weeks, which we want to tell you about now. And the first one is from Chalmers, and it's about identifying controller settings. The second one is from Chalmers as well, and it's about methods for strain gauge calibration. The third one is from OST and ETH together, and it's about improving the open fast model I mentioned of the Aventa turbine. And the fourth one is then an ECN student challenge, which is about 3D aerodynamic correction models, which we're now going to go through and tell you more about. And what you do once you get access to the digital platform, which I'll show you, you can then sign up for individual challenges. And depending on how many people want to take part in each challenge, we'll organize the group depending on it. We don't really know how many people are interested in which challenge yet. So now I'd like to pass over to Chalmers. I don't know who's going to speak. Hakan, probably. I just copied the goals in here, but I think you've got something to present yourself. Can I pass over to you to talk about your challenge or challenges for the next couple of minutes?
Yes,
Nathan is
Let's
nodding.
see if I can share this window like this.
Yep.
You see it?
Yeah.
Great. So I just put the names of the people that are in the meeting. Me, Sara Fogelström, and Ola Karlsson have sort of been here at Chalmers University of Technology. Sorry. You mentioned the turbine that we have, which is well, big if you stand next to it, but small if you put the turbine next to another turbine or a commercial turbine. And we have a quite detailed set of sensors on it. We collect operational data when it's running the turbine. And so we have a lot of signals at our disposal. And our challenge is maybe not for this turbine, but this turbine is the test case, we can say, is that if we consider and look at SCADA or other operational data from turbines, we typically get this data without specific knowledge of the turbine itself, and in particular the settings of the controller. So we would like to see if there is possible to, based on just the data, operational data, which is signals stored as a function of time, some signals, what can we reproduce the good representation of the controller? And one question then comes, which signals are critical and which can we live without? And how good do we get for certain signals? Because it's not always the case, at least in my experience, that one gets exactly the signals that one wants. So we brought up sort of 4 sub-challenges. So we're thinking in the following line. Say that you're given this data set that is for the Chalmers Test Wind Turbine. Is it possible to identify the controllers if we know the architecture? For instance, this NREL discount controller that was implemented on Chalmers Wind Turbine. And we know that there is some relation between rotor speed and the set point of the torque in the electrical machine. And this is given by some parameters. You see them here, VS, CT, and speed, and so on, corresponding to different regions. And then we have measurement data, operational data from the turbine that only covers part of it. And how should we properly identify the parameters from this measurement data? And the next step would maybe be not to only use a given architecture, but rather think how could the rotor speed, torque lookup table look like? What would that be? The third one is what we perceive more seeing is that in some situation we would like to change the setting of the controller to run it in a different mode. For instance, when you do curtailment or if you do some kind of ancillary services for the grid, you would like to be able to increase or reduce the production. So not only do we want to identify the control, but also to be able to identify when we change the setting of the controller. So if you have a year-long data, what are the instances you run with one set of parameters and one when you run with a different set of parameters? And how do you distinguish between the one case where you just have noise or if it's that you actually change the operation mode? A fourth challenge would be to identify a pitch control algorithm, because that is also one part that can be a challenge where you have some measurements and you would like to know how did it choose this. For each of these sub-challenges, it is not easy not only to find what is the absolute best way, but also to decide which signals to use if we have these 69 channels at our disposal. I have not defined, one can define metrics, what is the best possible solution, but here I think one can of course accurately measure the best possible solution. But it can be sometimes you can have a worse solution, but you only choose very fundamental signals. So of course that's a very good solution if you can choose very few number of signals, but still get a good, decent response. So this was the first challenge. We can turn to the second challenge. And this is a practical problem that occurred. So it's the same dataset as the previous challenge. Is that on our turbine, we have installed strain gauges in the blades. So they are small mechanical devices that are glued on the inside of the blade. You can maybe guess from the picture here. And there are cables, electrical cables that collect the signal from the blade. And that is a big white thing you see inside the blade there. And we know from the design of the sensor that there should be a linear relation between the signal S and the bending moment at the position of the signal of the sensor. So there should be some slope and offset parameters K and M. And typically they should be constant. They shouldn't depend on anything. That's a good measurement. But we see from our experience that they actually do. And it seems that there is a variation with the temperature, or maybe if there is a sunshine on the blade. So we would like to get help to find what is the best way to determine K and M from the operational data. So we assume that in the short run, in the second scale or maybe minute scale, there is this K and M, these parameters for the sensors are maybe constant. But if you run over a day, then they vary. So how can we distinguish between the short term and the long term? And can we maybe find even correlations between the signals K and M, the signal constants K and M, with maybe temperature, sunshine, if there is a tower shadow or not, or something like that. So this is also a bit of exploratory. What is a good way to do this? Because we need to take into account all the other parameters from the set. For instance, what is the rotor torque? Maybe that can help when we combine the bending moment on the blades. And then we have an additional challenge that is not yet published because the data is not yet published. And that is that also in the tower of this turbine, there are strain gauges installed. And the same question comes there. But these sensors are collected in a slightly different file, and this has not been added to the existing files yet. So hopefully we can publish these files and this data as well, and then this can be a challenge that might be a little simpler actually than the previous challenge with the blade sensors, because here the tower is where it is and it's not rotating, it's standing still roughly. Okay, so these were my 2 challenges from Chalmers.
Perfect. Thank you. Any questions about that? The details are obviously going to be published.
Yes, and maybe we could arrange some kind of seminar for those that are interested.
Yeah. So the idea would be once people have signed up, they will have a launch for the people who have signed up, and then we can talk about the details of each one and who wants to do each one and stuff like that. But maybe there's
because then one could discuss more practical issues with the data.
Yeah,
that is good to know.
Yeah. We don't need to do that now, but maybe somebody has if anyone's got any questions, sort of about that in general, feel free to ask.
May I make a comment? This is not a question, it's just a quick comment, and that's the fact that these challenges and the other 2 challenges that you will hear about are very, very technical in nature, meaning that they could also be very suitable for master students from universities. So don't just wait for people to show up in these challenges. Maybe you can advertise for those in our university. So even students who approaches us and you for master's thesis, they can be directed to these challenges automatically and not trying to come up with fictional projects. So these are real projects with real data, and they can participate and write their thesis on. And it would be nice to have, I don't know, 10 students from different universities working on the same master thesis independently.
So, actually, Emma, you'll see, this is perfect that you say this, because you'll see in a minute when Gerard talks, after you talk, that there's a...
Will he talk?
Yeah, he'll talk. Yeah, there's an ECN challenge, and we've actually called it a student challenge. And so the idea is that for that one obviously this can be applied to any of the challenges, but the idea was to just originally take this one challenge and actually call that a student project and do exactly what you said. Actually, we're going to publish a template for a student project. And then the idea would be that supervisors come along and take that template and actually get students to do theses on that challenge. So we've been thinking alike. So yeah. I'm glad that you said. Okay, so the next, we just need to move on a little bit just because of the time. But the next thing is, Imad, just to maybe just say, I made one slide just to say a couple of words about what we're thinking about for this challenge.
Yeah, so as Sarah mentioned, we have two identical turbines, which are our own research turbines. They're completely open, but they are 21-year-old, and their technical documentation and design documentation are sparse or non-existent. So we tried to create an open fast model, which is an aeroelastic model that we can use to simulate the behavior of these turbines, but they are lacking in many ways. And they are lacking in three fundamental ways, which are the topic of these of the challenges or the sub-challenges under this big challenge. Number one is similar to the Chalmers challenges. To start with, is simply improving the current control setup. So take some of the measurements that we have on the turbine and use it to tune the current control system on the numerical model. So it's not a very difficult task, but you need some understanding of the control system. So that could easily be a bachelor project for a student in electrical or controls in engineering. The second one is more mechanical and structural in nature. And that's the idea that we have the geometry of the tower and the blades. We have information about the material properties or the material constitution of each one of these two components, the blades and the tower. But we would like to convert this information into structural data in the aeroelastic models. So these are cross-sectional mass distributions, cross-sectional equivalent stiffness distribution, edgewise, flapwise, in addition to the aerodynamic information. So we have the basic open fast model available, but it needs proper tuning. And there are a lot of ways of doing tuning, Bayesian approaches or other approaches. And it's a very nice challenge. A lot of people work in such a topic in inverse problems. So I wouldn't say they're easy. There are data available, structural health monitoring data in the field. We have experimental model analysis data for the blades themselves. The tower is concrete. So there's a lot of things, a lot of data available to make this challenge manageable and approachable for students at different levels, or people in the industry who want to show how good they are. That's it.
Yeah, and maybe we just mention the connection with your space. So the space I mentioned, the RTDT, it's actually called the RTDT Research Affiliate Program space.
Yeah, and that space also uses data from this turbine, but they are very topical. So they are three data sets related to very specific use cases. One of them is system identification of the turbine in general, using operation model analysis. So we have structural health monitoring and SCADA data representing normal operation of the turbine. Another one is 3 days worth of high frequency data, which is pertaining to the identification of a damage on the pitch system, which completely shattered and broke suddenly. So the idea, can we forecast a few days in advance any early indicators of the damage progressing in time? And the last one is we made a controlled experiment where we put leading edge roughness on one of the blades. So we created fake leading edge erosion, in other words, and rotor aerodynamic imbalance. So the idea is having data from before the imbalance and during the imbalance. Can people identify the differences, or what are the aerodynamic or structural indicators that can be used to identify rotor imbalance beyond the classical, let's say, 1p or 2p frequencies from acceleration on the tower top.
Yeah.
So yeah.
So when you sign up, I'll show you how to do that. You can sign up for that one as well. Doesn't cost you anything, and you can have a look to see what's in there as well. Okay, and then we have the student challenge, which I think, Gerard, you could just briefly talk about.
I can explain that. I do not have any separate extra slides, but what is important for this assignment is that we recently uploaded data to the WeDoWind platform, and these are detailed aerodynamic measurements collected in the 1990s already. Within 2 projects from the IAA, the International Energy Agency, and these were then called IAA Task 14 and 18. One small thing, by the way, is that Sarah calls them ECN measurements. ECN does not exist anymore. We have become TNO. And ECN was the coordinator of these IAA tasks, but the measurements also come from others like NREL and DNO, but at DTO. But that is not essential for the things we discussed today.
We should change it, though. We should change it.
Yeah, okay. Yeah, but it's a small detail. What is more important is that although these are very old measurements, they are still, I believe they are still very unique, because there are hardly any of such detailed aerodynamic field measurements. And here we have data on 5 different turbines, which are also well documented. So we do have the turbine models for an open fast or something like that. And that is unique, because most of the few aerodynamic measurements we do have are then always taken on turbines for which we do not have the turbine data. Yeah, and the measurements we had at that time had as most important goal to develop 3D aerodynamic correction models, that's so-called stall delay models. And I'm not sure, I don't think we have many aerodynamic designers here, but if there are, they all will know these stall delay models. In a wind turbine design code like OpenFast, you often use 2D airflow data as input, but then they have correction formula for 3D effects, and that's mainly a so-called stall delay effect. And these correction models often have a kind of generalized form. They depend on a couple of chord over radius. They may depend on the pitch angle, maybe a few things more, but it's a generalized formula, but they have a few open parameters which are then calibrated with these measurements. And it's all about these calibration parameters, because these measurements from these IAA tasks have been used extensively already for calibrating these parameters already, but that was all manually. We had this model, we compared it to a few cases, and we tried to minimize differences with these parameters. But yeah, it was more or less visual, all manual trial and error. Yeah, and as a result, you see that almost every aerodynamicist has its own 3D model. So when Sarah told me that uploading data is not enough, we also need to build some exercises around these measurements with something new, preferably also students. We had a bit of a brainstorm a few weeks ago, and we decided to use these measurements again to calibrate these 3D stall delay models, but now with more modern methods. So that you do it automatically and not manual anymore. So we can run an uncertainty quantification tool on these measurements, and then you get the best estimate for the calibration parameter with an uncertainty estimate around it, but automatically in a much better defined way. So that there are still a few things to work out here. My idea is that every student is free to use what he or she wants to use for the calibration. If they have something, they can start already. If they do not have something, they can anyhow use a public tool which we developed in the national project with CWI, which is the Center of Mathematics and Informatics in Amsterdam. Actually, that tool is built around UQLab from ETH, but it's all public for students. And in a previous project of us, we linked it to our aeroelastic solver, and we did calibrations. But the people from CWI, and they already did it actually, also built it around other aeroelastic solvers. I know that students often use QBlade, so I think it can also build around that. But I know it is doable for students. It's not too difficult. It's not easy, but it is doable because we already had several students who used this tool in internships with us. One of them did exactly the same. He calibrated this 3D correction model, but with another set of wind tunnel measurements that all worked well within an internship. So it's all doable, and that's very reassuring.
That's great.
Yeah, and so that's proven to be doable. They also learn a lot because the students who worked with this tool in these internships all found good positions. Actually, one of them is now my colleague at TNO, so he can help me. But I also think the Aerodynamic Society will learn a lot because we get much better and much more general 3D models, and was very reassuring that I presented this idea an hour ago in an aerodynamic group meeting at TNO. Yeah, and really everyone was very enthusiastic and said that this calibration with the aerodynamic measurements from these IAA tasks, but with new tools, that's really a very good idea. So that's really very reassuring. It's not only me who finds it interesting. The only thing is, yeah, we still need to work out a few things.
Yeah.
This student at this moment who did this internship, he is a bit ill. It's not a flu. It will take a bit of time before he is recovered, and that I was counting on him to help me because he knows all the tricks and he knows what he came across. But yeah, in the meantime, we will proceed. It can be done relatively fast, but not within a few days. I was more thinking on a month or so, but before we have a more concrete description. But yeah, it's good to see that, yeah, also my colleagues here were very enthusiastic about it.
Great. Sounds like a great topic, and thank you for suggesting it. I want to, just because of the time, I want to jump on to like what makes this a student challenge. So the point is that this is just open for students, and they can take part officially by having a student project defined, which we can help you with, and we can help the supervisor. But anybody can take, any students can just take part without having a student project. But the extra thing the extra thing that we've got apart from that is a new thing, which is what I want Anna to quickly introduce. Bear in mind that I still need more than at least 5 minutes to talk about some other stuff. Sorry, we kind of run out of time, but I really want Anna to quickly introduce herself, because we want to actually use WeDoWind here to provide students with more added value. So Anna, please take the stage for a couple of minutes and tell us about that.
Yeah. I just added 2 slides. I don't know if they uploaded correctly. I don't know. Okay, so they didn't. I don't know.
No, I might have done. I just might need to just save it again, not open it again. You know, when I've got it open, it's probably not gonna work. But
maybe you have to reopen it again. Maybe I can just go ahead and start a little bit. Yeah. So currently, I'm from HR. Coming from the industry, in that case from the energy industry. I'm working for Badenova. It's a small energy utility in the southwestern part of Germany, in Freiburg. And yeah, I dedicated my work more or less my whole life for the development of people, of organizations. And I was really caught by Sarah's presentation that she held when I joined the executive program for renewable energy management at University St. Gallen. And so I was thinking about how can I just also make more contribution to the topic in general. And then she told me about her engagement here. And yeah, what I can really bring in is to support the student groups, for example, in becoming quicker, better in collaboration, for supporting them maybe for their further career. Like I could offer one-to-ones where we can just talk what is happening after university, so that they can just go ahead. I can also offer like facilitating workshops or retrospectives in the teams that are working on the challenges, so that they improve quicker when it comes to how they proceed their work. Yeah. So there's a lot of things to do. I also worked for university. I worked for the elevator industry. This is maybe why I also am in love with wind, because it's also a big machine, you know, and it's quite similar when it comes to gears and to controllers. It's not that far away from elevators. Yeah, and this is just how I might contribute. And I don't know why it didn't upload, because I put some more information on myself and yeah, where I'm working and everything, but let's see.
That's okay. It's fine. Thank you. And I'm really excited personally to have Anna's involvement as well, because the whole point of WeDoWind is, yeah, it's to get people working together, but it's also to provide these type of incentives. So if students take part and they also get this extra support. And I think one of the reasons why it's not concrete how Anna's going to support is because we want to wait to hear from you, the participants, to say what you actually need from her. So we will be asking this question to the people who are actually signed up for the challenge, for the space, I mean, probably in the first launch webinar. So yeah, thank you. I'm going to move on due to the time. We're only 15 minutes, no, 10 minutes behind. But what I want to quickly show you is a short demo of the digital platform, because sometimes it's a little bit difficult to use it at first. Before I allow a couple of minutes for questions. If you have questions, maybe start formulating them or even write them in the chat to save time while I'm talking. But generally, so what's going to happen when you sign up? Well, actually, maybe I can show the next slide first. There's a link that you can sign up to, which I'll put in the chat. And once you do that, you will nothing will happen immediately. But when the space is ready, fully ready in the next couple of weeks, you'll get then an introduction email from me explaining how you can access this digital space, and also inviting you to the first webinar. And when you get that email, you'll see a homepage that looks kind of like this, which has all the different spaces in that you've signed up for. You can sign up for other spaces if you want, and then you can click on the test turbine space. And this basically works a little bit like LinkedIn or something, that you see these different posts. My computer's really slow when I'm on Teams. It's not actually usually this slow. You see the space at the top. You can see the members. If you click on the members, you can actually see them all, and you can see the photos and maybe their email addresses, but maybe not. And then on the left-hand side, we can see different filters. If you don't do anything, you just see a load of different posts. So you see getting started, you see the different challenges, you see the different data sets. You can scroll around there, but you might get a bit lost. So the idea of this left-hand part is to actually, it's just a filter. So if you want to know, okay, where's the data, you click on there, and then you have, for example, here a list of data sets, which is just summarizing the different data sets we have, or you can just go directly to the different data sets. If you go to the code, you'll see this. We haven't done that part yet, but you'll be able to access, for example, the open fast code, which we told you about. If you go to challenges, you'll be able to see now these 4 different challenges, which we talked about. And then you can click on the challenge and you can see a description of how to solve it, how to take part. Actually, that was actually a really bad one to click on because we haven't finished it. But for example, the Chalmers, let me just go back to challenges. The Chalmers one, this one has got quite a lot of details in. So there's a background and the goal, and then there's a link to the data sets. And then it says, you know, the deadline is in June. You have to register as a participant. So you can click on there and you actually get to a document and a Google link where you can actually put your name in to sign up. You can, sorry, just takes a bit of time. You can also go to the general. There's some things about general, so it's an explanation of what the space is, how to get started, things like that. And so you can just interact with these different documents, and you should be able to navigate your way around. If something goes wrong, it might mean that you're not signed in. If you click on here, you can ask, the person should respond, Maria, otherwise you have to write to me. It's also a prototype, so it doesn't always work perfectly. You can also comment on things, but we can explain that in more detail once we get actually started. And Okay, and then so the next steps are basically, if you're interested in possibly taking part, you should go to this link, which I'm going to show you right now. If you go to the website and you scroll down, you get the different spaces. You can click on Test Turbine Committee space, and you get the description. And if you click on Join the Space, you get this form. You can, by the way, you can get to this form from the homepage as well, the top, if you just go to sign up. And on this form, you have to enter your name and stuff, but you then have to choose a space. So you can choose any space. And then, as I said, after that, eventually you will get an email from Relight, but you won't actually get access to the space until I give you access, and I'm not going to do that until we're ready. Then you'll get this welcome email, and then we're going to have monthly meetings at first where we actually discuss more of the details of each of the challenges. We can discuss with Anna how you want her to help you, and we actually decide which challenges to solve and what to do next. So there's no obligation. If you sign up, you can come along to the meetings. You don't have to. You can do what you want, but if you don't sign up, you're not going to know what's going on. So I would like to encourage you to do that now. I can put the link. I put the direct link to the form in the chat. Actually, now we've literally got 1 minute left for questions. But nobody's written anything in the chat, so there can't be anything completely unclear about what we talked about. Does anybody want to ask something? Is there something stupid or something totally unclear? Any prerequisites required to participate? No, that's the whole point. So the whole idea of this inclusive system is that anybody can take part. We actually want people with little experience in wind energy to come and interact with people who have a lot of experience, because that's how you develop innovative solutions, right? People have got different backgrounds and different experiences, and we want to embrace that. So no pre-requirements, please come. The only, yeah, that's it. Just come along if you feel like it. And there's no obligations and no pre-requirements. Apart from to be nice and smile and respect everybody. But that's obvious, right? All right. Well, yeah, you have to leave her. We all have to leave, I think. Thank you for listening, everyone. And if you're listening afterwards, because we've recorded it, thank you for listening too. And either email me. You've probably already had an email from me, but I'll put my email address in the chat, or email that email address on there, which goes to me anyway. Sign up if you're thinking about taking part. And as soon as we've got the space completely ready, and we'll send you invitations for the first meeting where we can talk about the details. So yeah, thank you again for coming along, and thanks for presenting, everybody, and everyone who's helped setting the whole thing up. Thank you very much, and hope to see many of you soon.
Thank you so much.
Bye. Thank you.
Bye.
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 Okay, bye.